In this question we are being told that S is the region bounded by the graph of a polar curve given by this function. And we are also given that theta is between 0 and square root of pi. And the question is to find the area of S. And this is just simply 1 over 2 square root of theta 1 to theta 2 r of theta squared d theta. This is a formula that we need to use here. And so let's just plug in our values here. 1/2 square root of from 0 to square root of pi r of theta 3 square root of theta sine theta squared d theta. And so let's use the calculator to calculate what this is. So let's calculate this expression. It's 1/2 times the integral from 0 to square root of pi for the function 3 times square root of x, doesn't matter whether it's x or theta, times sine x squared, close parentheses, close another parentheses, and this should be squared, and then this is dx. So let's calculate this expression, and we get the answer that area is 3.534. 3.534. In this part of the question we are being asked to find the average distance from the origin to a point on this curve. So basically the average value of this function for this interval. And it's the same for formula for either it's polar curve or a regular curve. So it will be equal to integral from a to b f of x dx divided by b minus a, or in this case it's going to be integral from 0 to square root of pi r of theta d theta divided by the square root of pi minus 0, or 1 over square root of pi integral 0 square root of pi 3 square root of theta sine theta squared d theta. And so let's use the calculator to calculate this value. So let's calculate this expression. It's 1 divided by the square root of pi times the integral from 0 to square root of pi of the function r of theta, which is 3 times square root of theta, or x in this case, doesn't matter, times sine of x squared, close parentheses, and our integrate with respect to x. Enter. So we see that the average distance from origin is 1.58, actually rounding slightly up, 1.58. In this part of the question we are being given that there is a line through the origin with some positive slopes that divide this region into two regions with equal areas. So let's say this is this line, and the slope of this line is m, and so this angle is theta. Theta, let's say 0. So we need to find this theta 0, and then in this case we are being asked to write an equation which involves one or more integrals whose solution gives us this value of m. How can we find them? And so first we need to connect m and theta 0. And we can see that tangent of theta 0 is equal to m, the slope of this line. So tangent of theta 0 is equal to m, or in that case theta 0 is equal to tangent -1 of m. And so let's write now this integral here. It's going to be integral from 0 to tangent -1 of m, 1/2 r of theta squared d theta. This will give us exactly 1/2 of the entire area. This will give us 1/2 of the entire area S that we calculated before, or in terms of integrals, it's 1/2, again 1/2 integral from 0 to square root of pi r of theta squared d theta. And so this is our equation, which will allow us to find them. In this part of the question, we are given a circle r equals k cosine theta, and we need to find the part of the region S such that it is within that circle as k goes to infinity. And so let's just draw a couple of those circles. So this is a circle, and this is point K in this particular case. So K over 2 is the center of that circle. And so then as K goes to infinity, both K over 2 moves to the right, K moves to the right, and eventually as K goes to infinity, this area AK is everything to the right of y-axis. So really what we need to find this area of S, which is to the right of the y-axis. So our answer will be 1/2 integral from 0 to pi over 2, because this is between angle 0 and angle pi over 2 of r theta squared d theta, which is 1/2 integral of 0 to pi over 2 parentheses 3 square root of theta sine of theta squared d theta. And again, let's use the calculator to find this value. So let's calculate this expression here. It's 1 divided by 2 times the integral this time it's from 0 to pi over 2 of the expression, and in parentheses we have 3 times square root of x times sine of x squared, close parentheses, and we need to have this entire expression close another parentheses, and then have the square here, because we have r of theta squared with respect to x. And the answer is 3.324, and this is the area, the limit of that area as k goes to infinity. So it's 3.324. Thank you, and I'll see you in the next video.